open a junk drawer and hunt for a pair of scissors. You'll dig past batteries, rubber bands, and old receipts before your hand finds them. Now picture that exact same pile of stuff living in a labeled toolbox instead. Same items, same total mess, but your hand lands on the scissors in under a second, and it goes further than you'd think. Because how you arrange information is a decision all its own, with its own trade-offs. A data structure is just a way of shaping information so that some operations get fast. Line your things up in a numbered row, an array, and finding item number 7 is instant. Jump straight to slot 7, no digging required. But squeeze something new into the middle of that row, and everything after it has to shuffle down one slot to make room. The more you're arranging, the more shuffling it costs. A linked list trades that away. Each item just points to the next one, so slipping something into the middle is one quick handoff, a relinked pointer. But finding item number 7 this way means hopping node to node from the front, 7 hops deep before you arrive. But what happens once there's too much to arrange in a single row at all? A tree arranges things hierarchically instead. One item at the top, branching down into smaller and smaller groups, like folders inside folders. Search a well-balanced tree, and each comparison throws away half of what's left, so even a million items narrow down to the right one in about 20 comparisons. But that speed depends entirely on staying balanced. Let the very same tree grow lopsided, leaning all to one side, and it degrades into exactly the slow row you started with, checking one item at a time. Push a little further, and hierarchy itself turns out to be just one option among many. A graph drops the strict top-down rule completely. Any item can connect to any other, with cycles and shortcuts a tree could never allow. A tree, it turns out, is really just a graph with one root and no cycles. And there's no single best shape. The right one depends on which operation you'll do most. Instant lookup favors an array. Cheap insertion favors a linked list. And search that still needs room to grow favors a balanced tree. So the next time you're digging through a junk drawer, remember, the information didn't change, only its shape did. And the shape is what decided how fast you could find what you needed.